Can you hear me now?
Yes, I can hear you. I was on mute, yes.
Okay, fine. So, let's begin again. Hello, everyone. This is Minna, and I'll be here as a tech support during the tutorial. And I want to introduce you to our tutor, Rania Elshenety. She's a data scientist at Henkel, Egypt, and she will hold the data science life cycle from a technical perspective tutorial. And so enjoy. Rania, you can start now.
Yes, just can you give me 1 second? Updating my connection. Okay. Can you hear me now?
Yes, yes.
Okay, perfect. Let me share my screen. Let's start. Okay, can you see my screen now?
Yes, it's working.
Okay, perfect. Okay, so hi everyone. This is Rania Elshenety. I'm going to be the lecturer for today's session, Data Science Lifecycle from a Technical Perspective. A very quick introduction about myself. I graduated from American University in Cairo 4 or 5 years ago, end of 2019, in actuarial science major, which is basically a major that talks about statistics and the application of statistics in our day-to-day lives. And one of these applications is actually data science, which we're talking about today. And when I decided to pursue my career in data science, I moved on and I decided to pursue my master's degree in from Michigan University. It's a program that's called Applied Data Science. It's an online program that you can find on Coursera. And since I graduated actually from AUC, I've been working in different companies, mainly in a consultancy company for almost 1.5 years. And then I joined Henkel 3 years ago with a total of 4+ years of experience in data science. And another thing that I do with working is that I really love teaching. I really love giving some data science stuff, data science courses or lectures. I started with an organization in Germany that's called Ready School, that they do some classes for refugees in Germany to help them in what we call courses like data science and other things. And I started to teach with them data analytics courses and machine learning 1 year ago, and I'm still doing it. And yeah, and this is why I'm actually here, doing something that I'm really passionate about, and at the same time giving you this a very brief introduction and some technical perspective of the data science lifecycle. So just to make sure, like everyone has the option to open their mics and speak, right? Any yes or no? No, okay. Let me check and okay, no problem. So okay. I'm not sure if there's someone from the team can help us in this, if it's an option to help people open their mics or not. But it would be cool to do this. If we're not able to do this, then what we can do is that, because I'd like to have some sort of an interactive session where we discuss together, either discuss or you just maybe put your comments or suggestions or questions in the chat if we can't open the mics. But yeah.
Yes, Rania, we can, but I need to everyone who want to speak to raise his hand, so the thing will be more organized.
Okay, so when they raise their hands, you can just like make them
Allow them.
allow them to
Yes,
speak.
allow
Okay.
them. Yes.
Okay, thanks. Great, thanks a lot. So yeah, let's just agree on this. I'd like this to be some sort of it's not like a tutorial. I'm not going to be working for the whole 2 hours and talking for the whole 2 hours. I'd prefer to have it come and go between us. So I'd like us to share. So yeah, as the team said, let's try to, if you have, like, when we have some questions or you want to interact, just raise your hand, and then they can allow you to speak from Zoom, and then we can have this interactive session. Okay, that's great. So let's start. So what we're talking about basically today is the data science life cycle. And what is the data science life cycle? It's and why it's important, and so on. So the data science life cycle basically is, we have a lot of different variations of the data science life cycle. You can see 5 steps, 6 steps. You can have additions and something is not removed from it in different versions. But the idea is basically to put the data science project in a cycle, like to have a cycle that starts and ends the projects, and help you throughout the process to know where you are, what's next, what to go back. The idea of also of a cycle is that you can always go back to a different step. Like it doesn't have always to be the first and then second and then third. No, you can always get back to a previous step, because sometimes some things are missing, some things are added, and so on. That's why it's a cycle that it's ongoing. And what we're going to be covering today, we're going to cover the data science lifecycle in more technical perspective. And by technical perspective, meaning let's get into more deeper level. Let's check what in real life scenarios, what should we do in every single step. We shouldn't really focus, like, if you're a data scientist or working as a data scientist, your your job is not only to do a model and just leave the model as it is when it's with a very high result. No, your job is to kind of manipulate the whole discussion from starting with the business understanding until you develop and you present a full solution or full data science solution. And sometimes in different companies, it depends on your job role. Sometimes you can have someone to support with you, some project managers, some data analysts, some data engineers, and sometimes you're doing this all on your own. And even if you have people supporting, it's very good to have a data scientist in the place discussing everything, because at the end, you're the one doing the main thing and the model. And that's why you need to understand what the people want, what the business, what the project needs, and so on. So that's very briefly about the data science lifecycle. So what today I'm presenting to you kind of one of the variations of the data science lifecycle that we'll be covering today. It contains 5 different phases, and for every phase we'll go deeper together. We will discuss together what we should do, and different things in every phase. So the first one is the business understanding. Very briefly, it means that when you start a project, most of the time, if you're in a company that do data science projects, and we have clients coming for you asking for some data science solution, or in your company yourself, you have like business teams coming to you trying to build data science projects. They come and they have a problem that they want you to solve, and this is the phase of business understanding, where you try to solve the problem by data science solution. And here there is a lot of discussions going back and forth between the technical team and the business team to try to find out what is exactly the problem, how can we solve it using data science, how can we plan for this, what's our exact and clear scope for to be very clear for the business and for the technical team. Sometimes this discussion can take very long time, but it's very important to have a very clear and concrete result at the end of this phase, because if you don't, then maybe what you do in all the other 4 phases really will be meaningless at some point if you're not doing what the business exactly needs. Sometimes you might just do something else or something that's not exactly the same, and then you end up feeling that all the efforts are not what exactly they needed. So it's very important to focus on this part in the project and to plan for it well. We will also talk into more details about it. The second part is the data understanding. So once you decide on a problem or what to solve, how to solve this problem, the data science shape of the project and so on, you start to see the available data and you want to understand. And because data is your main asset and most important asset in your project, you need to understand it very well. And here we can have this data analysis profile sometimes. And that's why a data scientist should be working on their data analysis skills very well, because inside the data science projects there is a huge part that contains data analysis. You need to analyze the data very well, you need to understand what it means, if it's going to help you, and so on. And here also it takes a lot of time, and it takes a lot of discussions with the business, because sometimes the data is really very different. If it's in a different expertise than your expertise, if you're taking a medical data set, for example, or a financial data set, where there's a lot of things that you don't really understand, you have to go back and forth with the business to try to understand the meaning of every column and so on. In the data understanding phase, afterwards, you now understand the data, analyze it, but then you need to pre-process it. And by pre-processing, I basically just prefer to say that we're trying to prepare the relevant data to be put in a model. So the data pre-processing is basically based on our data understanding, based on the analysis that we did. We need to do some steps to prepare the data set to be able to be inputted in a model, which will try to solve our problem. And then we move on to the modeling and evaluation. And basically, of course, we here try different models, try to choose the best model, evaluate the models, and present the results, and so on. And finally, after modeling and finding the final model, we deploy our model. And therefore, and here also there is a lot of discussion. It depends again on every use case and every data science project, how we want to deploy it, how after deployment what happens, because sometimes data scientists and a lot of people think that it's only about just I finish my model, and sometimes they just finish the model as it is, and they prefer that, for example, a data engineer comes and deploy the model, or even if a data scientist deploy the model in a certain way, they kind of okay, go away and leave it as it is. But there is a very important point that we need always to consider, which is the monitoring. Actually, for me, I always prefer that what's most important than building a model is making sure that the model is actually the maintenance and the hypercare of this model, because we're not expecting that all models would really work perfectly or work as good as they started for a very long time, because we always have new data coming and new patterns, and at some point the model might need to be retrained. And how to know this? We can't really depend on the business coming to us and saying your model is not doing well anymore. No, a good data scientist actually does this, like it's doing this as a speeder level, meaning that the data scientist should kind of prepare some sort of a code or a script that monitors the performance. And we already have this already deployed in a lot of in Microsoft and so on. You already have monitoring pipelines and so on that can help you. But even though if you're not using any of those systems, you can build a monitoring solution by your own, just building a script that monitors your results, the model's predictions, and monitors if whenever the accuracy or the metric starts to go lower or so on, you start to take an action before even the business noticing it. This is actually a successful project. So yeah, this is a very brief discussion or very brief description of the data science life cycle. So far in what I described, do you have any questions? You can here raise your hands, you can type in the chat. I think we have a question from Yusuf.
Hello, Mr.
Yes.
Rania. Mrs. Rania.
Yes. Hello.
I can understand from your talk, modeling steps is not important.
Is not on what?
Is not important.
No, of course. No, it's very important because actually
But
you're modeling, but
but
it's
if it's have not it's haven't a lot of coding or intensive in intensive pre-processing or deploying the model or business understanding. Yes.
yes.
So
So
how I deploy my model, I when I train deep learning model, I have a
mhm,
problem creating metadata in mobile application. It's very hard for me to create
mhm,
metadata for my model using
mhm,
TensorFlow.
mhm.
If you guide me for this, I will appreciate it.
Well, okay, thanks Yusuf for the question and for everything. So let me just um like confirm something that you already said. It's not about like modeling is not important, but as you said, maybe in coding perspective, like if you said that you're working with deep learning, and of course deep learning is much more advanced models than the normal machine learning models. But looking at normal machine learning models, for example, you'd find if you're building a very normal data science project, if you're doing the pre-processing of the data and the analyzing of the data, you might write a lot of code or spend a lot of time, not only write a lot of code, but spend a lot of time to analyze it. But then the modeling, sometimes you're just writing the model as the structure of the model you have. And the modeling phase does not take a very long time with respect to the data understanding part. But this doesn't mean that the modeling part is not important, because again, it's the most important part. This is where you, not the most important, but it's very important, because again, this is actually the objective of the project is to predict something using this model. But again, taking one step back, if you put not good data or not good data, then the output is not going to be good. If you know the code that says garbage in, garbage out. So as important as having a good model, it's very important to have very good and clean data that is actually representative of your population, that's actually containing features that are relevant for your project to have good results. Regarding your question about the deep learning model, I think we can take this discussion outside the session, because we won't really have time to discuss like how to deploy this right now. I can definitely help you after the session. We can have a discussion outside it, but because today the time is a bit tight, because we will
Thank you
dive
very
into
much. Thank you very much.
phase.
I appreciated your answer.
You're welcome. Thank you. I think we have. Do you have any other questions? Yes, we have a question that says, is data science life cycle is different than LLM life cycle? Well, I think the idea of building a data science, so LLM is part of the models, like large language models is like it's one type of model. Like it's not like it's not a different, it's not a different project. It's again one type of machine learning models or data science models. So again, when you start to do LLM, because we were having this discussion in work a couple of days ago, it's not the idea of going to work with a new model. It's the idea of identifying what you need as a business or what you need as a problem, and then finding the technicalities or the technical model that will help you. So LLM is one type of the models, and it's not different. So you need to have a business understanding. You need to have a problem that you want to answer. You need to have some data set, and then apply the LLM as a model in the modeling and evaluation phase. So I hope I answered this question. We have, yes, another.
I have a question, please.
Yes, sure.
How the data scientists, especially in Egypt, overcome the problem of trusting in results of AI or machine learning in general? As in many applications, it's a black box solving problems. So maybe it doesn't meet requirements of customers. I hope you understand me.
You mean by meeting the requirements? You
Trusting
mean
in
that
black box? Yes, it's a black box, mainly in deep learning or neural networks applications or solving problems. It's a black box. There is no explanation of how the answer is we get, and this sort of issues that meet data scientists in general, or who working in machine learning field.
Yes, I understand your question. I ask you to mute yourself, because I'm hearing myself, and then I can.
You don't
No, I will answer you, but when you're opening your mic, I can hear my voice. There is an echo. So if you can just close the mic, and I can answer your question. Yes, that's good. Thanks a lot, Sahar. So you have a very good question in this, and this is a very good point, because yes, there is a lot of there's a big issue in the idea of trusting black box models, and it's actually ongoing in different companies. And I know that there are different companies that would prefer to start with not those black box models, like work with models that can be interpretable. And by meaning interpretable, we know why this model predicted this actual result. Like for example, if we have normal machine learning models that would show you the feature importance, that would show you the equations and so on. But the idea, yes, we have the struggle of the black box models, and as I told you, I know some companies that won't prefer to start with those black box models because they can't really interpret the results, especially for the business. And yeah, because sometimes the business would ask, okay, why did the model do this? And if I can't get an answer, it really sometimes breaches the trust to be a data scientist, and you don't really get the answer because, as you said, it's a black box. But honestly, I think that why people would, for example, go to black box models like deep learning or advanced models is that because the results are actually very good, and how they trust that those results are really good is that we do a lot of tests. You train on different data, you test on different data, and you see the performance of the model over time. So if the performance of the model over time is doing well, it's not like there is no like variations in the data results and so on. This might make the people gain some trust in the results, but there will always be this gap because of the black box. I don't think that this gap will ever be solved, because it's always, if you put yourself instead of the user's place or the business place, if you I'm giving you a solution, I'm not telling you how it's performing, but it's performing really well. So maybe you would be biased towards the performance, the well performance, and you go with this good performance, but then you still have this question inside you: why did it do this, and why don't I know how it did this? So there is some sort of a not complete trust in the solutions, and I don't think that this might be solved, because the main part, which is not knowing how it works for business people, for example, is not answered. So sometimes people would work with black box models from a business perspective because they have very good results. So they might, give say, okay, we don't really have to know what's inside as long as it performs very well. But from my experience and from what I see, there is a lot of people who actually care about how the results, how the model gets those results out. So if you don't have some sort of interpretability for this model, then actually they won't prefer to have black box models. It depends on the business, it depends on the problem, depends even on how the model performs. But yeah, I have you agree to your point. It's a black box issue. I don't think I'm not sure if it will be solved anytime soon if we're still having this black box issue. Okay, I'm not sure if I answered the question, Zahar. If you have any other comments, I think. So I have a.
Thank you very much. Thank you. Yes, yes.
You're welcome.
Thank you. But there is a new field called explanation AI. I think it's a recent field of research, and I think it will solve this problem maybe in the coming years.
I think that would be good. Okay, so I just think instead of I know that we have a lot of questions, we can start with this our session, and then if the general questions we can push them at the end of the session. We are going to have session time for Q&A, but just to make sure that our time is we'll be able to cover the 5 phases, because I think it's very good to, I don't want us to miss something from them. So I see there are questions in the chat. I'm not going to leave them. I can answer them at the end of the session. And if for any reason we did not have time, we can also connect after the session for any discussions. Okay, so let's move on to our technically presentation. Okay. So we have, let's put a scenario. So before actually diving into it, I showed you the data science lifecycle, how it goes. We discussed it a bit, and we want to get a scenario that's a very generic scenario anyone can meet in our day-to-day life, but we want to apply our data science lifecycle on it, and we want to discuss through it. So you're a data scientist in a company and you find the business, or you're a data scientist in a technical company and a certain business is approaching you, or in your certain company, the business team is approaching you and they have a certain problem that they want you to solve. And they come and say, you're for example, in an FMCG company, we have consumers, we have a lot of consumers, you sell consumer goods, and the business team comes to you and say, we want to build a data science solution or use data science to analyze the customer's behavior or payment behavior, and we want to use predictive modeling. So this is a very generic this is a very generic thing that they want to apply, and now we want to, based on this very generic discussion, we want to apply our our data science life cycle phases. So let's start with, for example, the business understanding. So maybe quickly just type in the chat. You don't even have to open the mic. If in the business understanding, what do you think what we should do? So now we have a business coming with this technical problem, which is they want to analyze the customer's payment behavior and use predictive modeling in it. In the business understanding phase, what should we do as a data scientists? And you can definitely type in the chat if it's going to be easier and quicker. Any suggestions on what to do in this phase? Okay. Communicate with customers, especially at the beginning. Ask as many questions that can be relevant as possible. Ask questions to find out the main issue to investigate. Collect the data, what they need exactly, like KPIs, do ADA, meet the stakeholders. Actually, you summarized technically mainly. So the very important thing that we actually need to do is ask questions, and ask as many questions as we can, because this is the phase where you can ask as much questions you can ask, because afterwards, when you start working with the data and you start building the model, it won't really make sense for you to come and ask a very basic question. So it would make sense to ask as many questions as you can. And by asking questions, there is a lot of different. So you can see, for example, we want to see what is the actual problem. So you want to do a customer analysis. Is there a certain objective for this? Do you have a certain problem that you want to solve? Do you actually have data for the customers, or you don't really have data? And if you even have data, sometimes in big or large companies, there might be data, but you don't always have access to it. Actually, sometimes it takes a lot of months to get access. So do you actually have access to it? What's the output should be like? What else should we ask if you have any idea? Again, what made them ask this question? This is important to know if what they ask is what they really need or not, and this is a very important point. That's why asking questions to the business is very important, because sometimes they really say that they want something, but when you look at their problem, you figure out that what they need is not exactly what they communicated. So that's why it's very important to understand the process. Okay, what's their process? Why do you want to do this? Is there a certain process that when we do this model, it will enhance this process, it will solve something, it will save efforts, it will save time, it will get revenue, and so on. And of course, understand the time frame and the budget, because it's very common issue is that the business would come and they would give you a problem, and then you would formulate the problem, you'd formulate the scope, and when you start to work, you figure out there is no budget for this working. Another issue is that they would because again, not all business teams understand how data science works. So sometimes they would come and just ask you about something, and then we would say, okay, we will expect results in the next 2 weeks. And actually getting data would take 2 to 3 to 5 weeks. So it's very important to understand what's their time frame, what do they actually want to do, and so on. In addition to asking question, we need to understand the value and the risks. What's the value? What's the expected value from this solution? Like, is it going to add something, remove something, like add more revenue to the company, for example, and so on? Is there a potential risk in the whole process? For example, if you're dealing with customer data, we're now looking at customer. Are we allowed actually to look at very detailed customer data, or it's going to be is there certain security or privacy issue? What are going to be our challenges? For example, they might tell you, we want to analyze the customer's data, but unfortunately our customer's data is kept in paper work. for example, which is not happening, of course, anymore. But like, if it is happening, this is a very important challenge. We really need to transform this data, or it's in a place that there is no access to it, that we need to do a lot of permissions to get this access. What are also the challenges that we might face, so we can even plan for it? Because it's very important to plan where you're planning for your data science project, to plan for ad hoc things, to plan for emergency, because this happens. Like, from my experience, I think I never worked on a data science project without having an emergency occurring, popping up, that has to do with data, that has to do with discussions, and that would make things take much more time than it was expected. So it's very important when you're planning even your timeline and your action plan to take into consideration these ad hoc and these emergency things and these risks. So very important thing to understand as a data scientist, what is the problem type? So what do they want? So for example, are we looking here, do they want to actually predict a certain number? They want to calculate a certain number, predict a number like a regression? They want to categorize people to certain classification, or they want to group people together and see what the clustering? Do they want to kind of detect a certain thing that doesn't happen normally, like outlier detection? Do you want to build a recommendation system, and so on? Based on your discussion, based on your questions that you ask, you will try to figure out what's the objective again. Because again, you might be talking with the business for a very long time, and then you figure out that you don't know what they actually want. This is a very tricky thing that happens. Business people know very well how to talk. They can talk to you dozens of hours, and then you can figure out as a data scientist at the end that you don't know what they want. That's why when you enter a business understanding meeting as a data scientist, even if you have people supporting, you have to have a very clear set of points that you want to achieve at the end of the meeting. And you have to see while throughout the meeting if you're answering those questions or not, and make sure when you get out of the meeting that you don't get out until you have those questions answered. And one of those questions is actually, what's the target variable that we're trying to predict, and therefore we're getting here to the machine learning problem. And what do you think the output of this phase will be? So you can type in the chat. What do you think when you get into those meetings with the business? You ask the questions, you define the values, you define the problem, and so on. What's the output here? Like the output of this exact phase? Predictions. Okay. This is a question or an answer? Let's see if other people can say a data set. Okay. A clear and concise understanding of the problem and the desired outcome. Insights, identify the problem. What the Q, knowing the problem to formulate the model, the full system requirements. Okay. That's we have a lot of, okay, good, that's very well. So what we're doing right now is about, actually we're asking about the problem. So what's the problem, or what's the objective? And we're defining the basic idea, as exactly the last answer says, problem definition and data, and basic idea how to solve it. So yeah, we kind of now understand what's the problem. So we asked many questions to understand the problem or the objective. We now know how it will affect the business process, and we now know if the data is available or not, because it's one of our questions that we need to understand. So we get out with the problem defined, we get out, which we also called a scope definition. If you enter business meetings, there is also this scope definition. So we define the scope with objectives, with timetable, with a time plan, deliverables. What should we be expected as data scientists to deliver? It's also very important to agree on this, because sometimes you expect, okay, you're not delivering a pickle model. You'll be delivering an overall solution for the business. Or maybe sometimes they would ask the solution to be delivered in a dashboard, or in a certain way, in a certain deployment way. So it's very important to understand how you should deliver even your output, because you might be doing a very good job in the machine learning model or model that you're building, and then you figure out that the business actually is not okay. Where's the output? What are we going to take? That means, is it that mean if you have the concept and tech skills and not able to solve real problem, it's hard to get? So I'm not sure what do you mean by having the concept and tech skills but not being able to solve the real problem. But technically, if you have tech skills like data science skills and you know how to discuss with the business, you can solve the problem. And you can solve the problem, and therefore you can get a job, of course. And by the way, you're not always expected as a data scientist to actually do all those discussions on your own. Again, it depends on your job and the company, because sometimes the job is not all sometimes the job is just about doing the models. You don't really get into the data or the business meetings. Sometimes, for example, your manager does this and gives you the exact work. But honestly, from experience, it's very good to attend those meetings, because it's very good to get the project from start to end, to discuss with the business, know what they know. And actually, when you build the model, you kind of understand what's the output of this model, how it will help the business. So of course, if you only have data science skills, you can always get a job. But the idea, if you're going to be in a job and learning how to build a project from scratch with the business, you have to learn how to do this, and it's actually learnable. Like, we don't take in eh, data science. Yes, it's about, of course, the modeling and coding and so on, but also it's very good to learn the additional parts, like discussing with the business and communicating with them and finding a certain background, a certain common ground to stand with the business in. So yeah, so let's move on back to our scenario. So if you remember our scenario, the business wanted to analyze the customers and now the customer behaviors, and now we need to approach them and ask them some questions. And based on our data business understanding phase and what we suggested together, that we need to understand some things, we have some questions. What can we ask those questions? Those questions could be, for example, those questions could be, for example, where is the data? Do we have data? The questions could be, for example, do you have actually data? How can this help you? And before actually data, we need to understand the value. What is the value that this project will give you? Will it save something? Will it make your processes more efficient, and so on? And you're saying here you want to predict a payment early or late. So does it mean here that the output is going to be an early or late, which is technically a classification from our background? So actually, how are we going to do this? Do you have a certain threshold that you're going to decide, okay, this is a late customer or an early customer? And another thing is that, for example, let's see together what questions. What's the potential value from this project? Another thing is, do we have data about customers, and actually do we have access to it? And how to determine early or late payers? And how do you expect the output to look like as a business? And finally, we can see that, one second. And yeah, what's the frequency of running the model? So do you want, this is very important, because again, do we mean that we're going to do our model and just produce predictions and give them the predictions and that's it? No, in day-to-day life, in day-to-day data science projects, what you actually do is that you discuss with the business that you are going to run this model daily, every week, every month, and the predictions will then be saved in a certain place or a platform, depending on where you work and the project and so on. It's also very important because sometimes if something would be deployed in a certain way and run, for example, daily, then you will actually have to discuss with your team that you might need some people to support from a technical perspective on the certain platform that you're working on. Or even if you are going to be the one building this part, you need to plan for this. So it's very important also to understand what's the frequency of doing this. Let's move on to the next step. So now we ask those questions. What will be their answer? Let's see. So now they want to tell us, okay, we want to analyze the behavior of the past behavior of the customers and use predictive modeling. And now we want to say that, okay, how will this give us value? This will give us value is that now, instead of when we approach customers by, for example, reminding them on their due date. So when we approach them, instead of approaching all customers with the same way, we now know that we have late payers and early payers, and the late payers, we will approach them And the early payers will not be approaching the same way because it doesn't make sense to approach all the same way. We now know that there are some people are late and some people are early. So we actually make it a customized way. So this is the value. We're going to customize the way we approach customers, and therefore we actually save a lot of the effort and the time of our team members who do this approaching. So we can see here the value. The other thing that we also look at is that the data. Yes, we have data for the last 5 years and we have access. And this is a very good point and checked in our checklist. And okay, how we identify, we're going to put a threshold that says if a customer does not pay after 3 days, then this is a late customer, and if they are paid before the 3 days, then they're early. So now we have this threshold to decide how early or late payers. And how the output would be and how frequent it will be. We want to put daily predictions to pre-presented in the dashboard. For example, they chose here Power BI, Microsoft Power BI dashboard, with a traffic light system based on the model predictions. And the traffic light system, like for example, if a customer is always early, then this is a green. If a customer is always late, it's a red. If it's a customer have some late and some early, it's going to be it would be highlighted in a yellow, for example. And here it's very important to understand how we're going to present the results. And why is this? Because, for example, you now know that you need to include Power BI in your process. Okay, do you know Power BI? Is it your job responsibility to actually develop a Power BI dashboard in your work? Maybe it's not. Maybe it is, but you don't know Power BI. And then the manager said, okay, no worries, you can just learn it. It's not really a hard thing. It's not really a hard thing, but it's a new thing that you want to learn when you're developing a new project. So you have to plan time for this. You have to plan time for if you're not going, if it's not your job and you need to contact someone, you and the data science team or your manager or whoever, you need to contact the team responsible for Power BI or data analysis or dashboards, whatever it's called, and ask them, okay, guys, we need someone to support us because we will build a model and then we need to connect the results of those models to Power BI and create a dashboard with the traffic light system. So those are all of the things that you will need to plan at the beginning of the project. So when you go back to the business with a time frame, you say, okay, we will take 2 months for the modeling, for example, and 1 month for the data for the Power BI dashboard, for example, and a certain colleague will be joining us. And all of this will be decided based on defining a very important scope. For example, if you don't have the last part, if you only know that you're going to do a model and get out the results, for example, as Excel files somewhere and they will look at it, you will just plan for the modeling, you'll just plan for it. And then afterwards, when the business would come at the end and say, okay, we wanted a dashboard, it will be here an issue. You would say, okay, you did not communicate this at the beginning, and they would be very frustrated because they did not meet what they want. And that's why it's very important to ask a lot of questions and to ask those specific ones and specifically. Okay, so before actually moving to the next phase, very quick, couple of minutes round of questions in this part specifically. If anyone has any questions, please type them quickly. If you have general questions, I'd prefer to leave them at the end of the session. But if you have questions in this specific part, please just send them. Regarding the comment about asking the customer about the frequency, yes, you're actually right. It's not always that the customer would actually have the right answer. Sometimes they don't really know. But it's a good question that you might ask, because maybe when you ask, you open doors for them to think about the frequency. I was working with a business team recently in a project. The business didn't know except actually the first sentence, and we had to do a lot of business meetings to find a lot of the things. And they would actually formulate things when we start asking them. They don't have the answers, but when you ask them, they start working to find those answers. So it's going to be actually good that you ask those questions, because even if they don't have the answer, they might start thinking of it. How to choose the best questions? Well, there is no certain templates, but I think we already mentioned the things that we need, like the things that we need to be covered. So for example, you need to get information about data. So this is very important questions. What is the deliverables, the time frame, how it will look like, the output, how it will look like. These are very important questions that you should have. Sometimes you might ask a lot of more questions that might not be very important, but again, the most important things that you want for the project, just think of it like this. What will you need throughout the project to make it smoothly? Data, access to data, information about data, information about how to get this target variable that you want to predict, what the output would be. So in a coding Python way, or not Python, but whatever coding way you're doing, it's the same. You're just getting data, analyzing, building a model, and then saving it as a pickle file. From this step on, forward on, what will happen? What will you do? This is a very important thing that you will learn from how the business expects the output and the shape of the output. Okay, I think we don't have any other questions. Okay, well, that's just last thing. Okay. Yeah, ChatGPT solves a lot of things. Let's move on to the next phase. Okay, the data understanding. So now we understood from the business what is the what we call the problem, what's the value, and we have access to data. So we need to understand data. And if you know the very well-known quotes about how long people and how long data scientists spend in the data understanding phase, they might even spend 80% of the whole project time in understanding and pre-processing the data. It's actually correct, because honestly, from experience, if you don't really spend enough time with data, and there is no actual time saying what's enough time, but if you don't spend a good amount of data, a good amount of time understanding data and getting insights from it and so on, one way or another, you'll have to get back to data to understand things. So it's always preferable to plan a good amount of time to understand data. And it depends from one person to another. Sometimes people are more experienced, they already know what to do. Sometimes if you're at the beginning of your working journey, you don't really know, so you plan more time. With experience, you'd understand that, okay, you know a lot of things to do, so you don't really need the same large amount of time. But even if you don't put a lot of time, but you know that in this specified time, you just go as deep as possible in the data understanding phase. And before I present what I have, can you please kind of, for example, give suggestions? What should we do in the data understanding? You can have 5 minutes in this discussion, whether you want to open the mic or just type in the chat easier. What should we do in the data understanding phase? Now we get the data, we have a data set or a couple of data sets, and we need to understand what is going on. Okay. Determine the outliers, features, size of data, EDA. That's very important. KPIs, kind of the process that it will be need to done. Understand each column, check histograms, feature plots, statistics. I think I don't need to explain, you know everything here, but that's very great. Yes, where data is stored and to collect them, understand what each field represents and what to do with it. The type of data, again, structured, unstructured, storing, querying, determining the features based on the problem understanding and expected output. Yes. Okay, that's very good. Okay, let's actually, you answered it. I'll try to summarize it with the slides that I have. So first of all, ingesting data. So we have data, but how to get it and where to get it from? Again, it depends on how you work. Sometimes you work in places where they can send you Excel files. But when you deploy, for example, in general, when you start developing your solution, you need to understand where is the data coming. Is it, for example, in a certain data platform that you're going to call using data pipelines? Are you going to be the person doing it? Are you going to connect to someone to create those pipelines for you, and so on? So maybe as a first step, they would send you a snapshot of the data, a couple of years for you to analyze and understand how the data looks like. But actually, when you start working, you'll, for example, you need to do some data pipelines. So the understanding of this phase is very important. And as when you start working in big companies or with big companies that start to save their data and lake houses and data platforms and so on, it's not as easy as just clicking download the Excel file. No, you have to build some pipelines. So this is first of all accessing data and getting it on the pipelines. The second part of it, how many tables, for example, is it all the data? Is it saved in one table, or are we getting different tables? There is a project I'm working on. We have to get data from 7 different tables and then merging them together. So again, those 7 tables, you need to figure out how to merge them together. And it's very important because it would be tricky if you merged on something wrong, because the columns are repetitive. So how many tables? And when you actually get the final table and join them together, how many rows do you have? How many columns? The size of the data, and so on. And we actually do this with the EDA, exploratory data analysis. And the exploratory data analysis, we can actually have a long session discussing this exploratory data analysis. I love this phase, and it's really very important phase in the data science project lifecycle. But we can just discuss some points in it today, and hopefully maybe you could just maybe we can meet another time for this exploratory data analysis session. But the EDA, the exploratory data analysis, is basically we're exploring data, trying to get a lot of things, and next slide will show how to do this exploration. The most important part here is the plotting. A lot of people just decide to skip this plotting part, and honestly, it's very important. There is, of course, a lot of data. Now we have data sets with huge amount of columns and huge and plotting all of them is not really easy. But honestly, plotting helps you identify a lot of things. I used to have a professor in university that would always say, "What is the first thing that you should do when you have a data set?" And he would answer, "You need to plot it." And the second thing to do, he said, to plot it. And the third thing to do is actually, again, to plot it. That's why it's very important. You can see things by your own eye that the calculations and the statistics, mathematics statistics won't actually make you see. And yeah, so again, you need to, for example, to understand the data type, and we will see more how to do this analysis in the next slide, seeing the univariate, multivariate analysis, and so on. So we want to explore the data. After exploring the data, what should we do? Now we explored the data, we did all what you guys said, we plotted the data, we figured out where the outliers are, and so on. And then what should be the output of this phase? Clean data. Yeah, maybe clean data. We still have the data pre-processing phase. So maybe we can say steps for cleaning data, because we're still going to have the data pre-processing phase, which, if you remember the cycle we had at the beginning. Sometimes in certain, in different cycles, in actual work, you'll have two together. You'll understand data, and in the same code, you're just going to apply the cleaning data, and the output would be clean data. But if you were talking about the cycle that we're here talking about, which is understanding and then doing the pre-processing or the cleaning, then here we have the actual defined steps that would help us do the pre-processing and cleaning. And yeah, and I know that, of course, this doesn't apply for all types of data and all types of machine learning models like deep learning, but for this session, we're kind of focusing on normal traditional machine learning models, not like the deep learning images structured. But even though maybe for those the types of problems, you can even have similar steps, but the inside steps might not always be the same. Okay. Yes, feature extraction and engineering would also be the next step. And yeah, we can go to the last slide. Yes, 1 second. Yes. Decisions on what models to use. Yes. Okay. So now we here divided the understanding and the pre-processing to 2 phases. We are understanding the data, we're plotting it, we're exploring it without playing with it. We're not editing the data, we're now just looking at the data. And then what we'll be doing in the next step is actually when we have added the data, when we explore the data, we start to have some certain observations. We have a wrong thing here. We need to add, change this data type here. We need to fill this missing value. We have an outlier here, and so on. And we gather those observations together, and then have some certain steps that we will apply in the data pre-processing or cleaning process. Yes, we're going to expand right now on what to do in data pre-processing. So actually this part, the exploring data, it's actually what we do in pre-processing. So basically when we explore data, what we want to do, those are general points. We can even, as I told you, this exploratory data analysis and data analysis pre-processing part, we can have a 2-hour talk for it only, but I'll try to cover here as much as I can. Looking at time, yeah, okay. So we plot. We try to plot. So what do we plot? We have, I like always to do it, to divide it like the univariate analysis and multivariate. And by this we mean univariate, like every feature on its own, every variable. Let's look at the distribution of every variable. Is it continuous? Let's look at the histogram. Is it categorical? Let's look at the bar plot or the count plot to see the distribution of the different values. So this is kind of the univariate analysis. The multivariate analysis, it means looking at the correlations between different features. And we here look at the correlation plots. If you know the the pair plot that shows you the all the correlations between all the features in your data, and in the diagonal it shows you the distribution of every feature. This is a very good way of plotting, but of course if you have a lot of features it won't be very efficient to see it all in the same place. And yeah, again, if you have a lot of features at the same time, you don't have to plot them all at the same time. It won't make sense because actually it will take a long time to plot, and the big plot will be not, if you'll have a huge, you need a very huge screen to see it. There's a lot of ways to do it. You can plot every feature on your own. You can plot different groups together if you understand there is a certain correlation between them. There is I can't remember the name right now, but there was a package where you just it kind of produces an output, kind of a report for the data analysis. You give it the data and it gives you analysis for every feature, the graph for every feature, its interaction or correlation with all features, and so on. Hopefully I'll try to remember its name, but if I can't, then forgive me for this. Not like pandas, there is a plotting package or plotting library where you can just give it the data and it produce an HTML file for you with all the analysis. But of course, for plotting, you can use Seaborn, Matplotlib, and so on. So here the idea is plotting. Why do we want to plot? We want to look at the distributions. So how is the distribution looking? What are the different values? For numerical values, is the distribution normal? Is it very skewed, for example, to the left, and there is some sort of an outlier there on the right? And again, plotting helps a lot in identifying outliers, because in numerical essence, you can calculate different calculations to find outliers, like the IQR and so on. But actually, when you looking at the plot, it's more efficient in it. And this is for the outliers. Also, what we do is correlations. You can, again, look at correlations using the different correlations calculations on pandas or in whatever, depending on which language you're using. But again, looking at the graphs, it makes it more vivid to see the correlations between features. What's very important in this phase is actually to see the data types, because sometimes you'd find some numerical, it's numerical, but actually codes, like the customer key or the customer ID. The customer ID is just kind of a code, so it's not a numerical. So we shouldn't be dealing with it as a numerical, and so on with different things. And how many missing data do we have? How many actually rows do we have? So here, for example, if we're looking at the customer data, we're now going to analyze customer data. How many customers do we have? And what are the data types of the columns that we have? Do we have missing data? It's very important to deal with missing data, because missing data doesn't always mean, or like dealing with missing data doesn't always mean just let's delete it or let's just fill it with the mean. It doesn't make any sense, because sometimes missing data is missing on purpose. It needs to be missing. It needs to be empty. So it's important to understand why there is missing data and to see how to deal with it, remove it or interpolate it, and so on. Incorrect and inconsistent data. It's very common again. Sometimes, I mean, I still face it in my day-to-day life people a lot of time put inconsistent data. For example, if you're looking at the revenue of a certain company, and with this, there is a column that says the currency for this revenue. So the currency could be euro, dollar, Egyptian pound, and so on. And then, so this number of revenue is in this certain currency. So sometimes you'd find a huge number and you expect that, and you say that it's so, usually if you're looking at Egyptian pound versus US dollars, then you'll find a huge number in Egyptian pounds, but a very small number in dollars, because when you transform it, it's much smaller. But if you find a very huge number in USD terms, in dollars terms, it's a bit tricky for you, because if all our data, for example, the biggest revenue was $1,000 and this is $100,000, it might be suspicious to you, because maybe actually it meant to be in pounds, but the person who entered the data entered it wrongly. So that's why you analyze. You figure out, okay, if you're looking at the customer payments, let's see the customer payments across the years and see, okay, there is a very large number here that is very strange. There is a negative number. There is a very small, there is a zero number. Why do we actually have a zero payment? If it's a zero, then why do we have a row for it? These are questions that would help these are actually questions that you go back to the business after exploring the data. The date itself, sometimes you'd find a date that's 2030, for example, and how is a payment done in 2030 while we're still here in 2024? So it's very important, again, to analyze and look at data very specifically in this exploration data. Okay, and what else? Data types, distributions, missing data, incorrect, inconsistent, outliers. We're here not dealing with anything. Like, we're not going to fill the missing data. We're trying just to explore what we have in our data set. And the target analysis. It's very important to look at the target. So what's our target? Is it a numerical variable? Should we see its distribution? It's very important to see the distribution of your target variable, specifically if it's a numerical variable, because sometimes when you're modeling or you're predicting numbers, if it's a normal distribution, it would help you, which rarely is, but it would help you in choosing certain models. So again, distribution, if it's a categorical target, we'll see the distribution again, how many for each class, because here again we might face a very common problem, which is the imbalance. By imbalance, meaning what? If, for example, we want to predict early and late payers, and we will find that 90% of the data set are early payers, but only 10% is late payers, and it's very critical. So now your model will be trained majorly on early payers, and the late payers would be very low. So we'll have to think of how to deal with this, and there is a lot of ways to deal with this imbalance in the data. So that's why exploring data is very important. I try to put as much things to put here, like starting points to exploring the data. But as I told you, it can take us the 2 hours all to discuss them. But we will now move on to the scenario and see how to explore the data of this scenario. But just a quick couple of minutes if you have any questions. Yes, pandas profiling. Thank you. This is the package that I was that I wanted to say about. It's called panda profiling. Actually, it does mainly, if not all, it does most of it. You just give it the data set and it does all of this. I prefer to do it honestly on my own, but like it's also good. So if anyone has any questions here. I don't have any answers about the recording. I think the technical team can help you in this, and the slides I can share with the technical team, and they can also share with you. Any other questions that are general, I will postpone them to the end. I'm not leaving them unanswered, but I just want yeah, to let you know this. Okay, let's think. Okay, I don't see questions. I should filter features based on the correlation with each other, low to step threshold. We'll give a quick talk about the feature selection. and how to select, because there are different ways, and again there is no right answer because there is a lot of different ways to filter features or to choose features. So it depends on your problem, but we'll discuss them together. We'll dig deeper again in the feature part, feature engineering and selection part. Okay, let's move on again to the scenario. But let's quick. Okay. So data understanding. Now the business comes with the data set that contains those columns: the customer ID, the invoice that they pay, and the invoice's amount, the amount they have to pay, the due date of the invoice, the document date, like the exact date it was created, the payment date that the customer should pay in, the number of items inside each invoice, so if the customer is ordering multiple items, the country of the customer, the risk category of the customer. So we now have those columns and we want to analyze them. Just very also quick couple of minutes. I want you to share your ideas when you see those columns. What do you think? What could go wrong? Like, what issues could we detect in columns like these? We don't have the exact data, but we already gave a lot of ideas about what to explore in data and what could go wrong. So you have those columns. What do you think could go wrong in any of those? A customer ID, invoice ID is meaningless, doesn't add value to the target. Okay. I might have some points to discuss with this, but let's check the rest of the comments and maybe discuss them all together. Okay, we started having something. So first of all, customer ID, invoice ID are meaningless. While I might have some points in this, because if you want to predict, it depends on how you want to do the prediction. So if you're predicting per customer, then you need to have a customer ID taken into consideration. If predicting general invoices, like what I mean on invoice level, like for example, a certain invoice is coming on a certain date and certain features, then the output, then we don't need the customer ID. But if your prediction is dependent on the customer ID themselves, which is also not very recommended, because this means that you have a huge data set, but sometimes the customer ID is helpful in actually identifying if you're doing if you're doing the predictions based on the customer ID. Invoices ID might not be useful in some states. If your data granularity is very low, meaning that actually this data set might contain different, like multiple rows for the same customer and the same invoices ID. Meaning maybe a customer made an order or an invoice containing 5 items. So you'll have 5 rows for the same invoice, the same customer ID, the same payment date, the same everything, but the amount is different. Why? Because here it's the amount of the small part of the small category inside the invoice. And this actually will, if you explore this doing the data, this means that the next step would to group them together, add them together, and to have one for every invoice. And then the invoice ID will not be useful anymore. So yeah, that's important. One customer might have more than one invoice. So first of all, we can have the same invoice repeated because it has different constituents. So you need to group them together if you want to just analyze the invoice only. Customer might have more than one invoice. And here, this actually is a very common problem, is that a certain customer might have different invoices. So how are we going to build the predictions or the model? Is the model going to depend on the customer ID itself, or we're going to give the model different invoices across all the customers? So, and we're going to create some other features in addition to those features. So the prediction is not really dependent on the certain customer ID. It's dependent on the customer behavior. And how can we get this customer behavior? We can get the customer behavior from the features that we will create, like the category, the risk category, the customer country, and so on. So instead of keeping the customer ID as it is, we can actually remove it in this case, because we will have something different. We will have the customer payment behavior or customer overall behavior or characteristics from other features. So this is the idea about the customer ID and invoices ID. I'm not sure what could go wrong with customer country. I think if anyone suggests something would go wrong, you can say what could go wrong with the exact column. Due date and payment date are redundant. Actually, they're not, because due date is when you should pay. Payment date is when actually the customer paid. And actually these two columns are the ones that will help you define the payment behavior of the customer. So I did today, I ordered an invoice in this company. So today is whatever, 19th of April. The due date of my invoice is 19th of May, but I paid 10th of June. So these are 3 different dates. Okay. Unique key, that's very important to have a unique key, because again, if you want to do some sort of an analysis on a customer, you can use the customer ID, the invoices ID, and actually I might surprise you, can also use the country, but we can use it later on when we talk about the features. But yeah, you have to have a unique ID. What's your unique? It's the customer, or are you looking only at the customer, or you're looking at the customer per invoice? And again, this should be a good question to discuss with the business. Do they want to for example, to look at the invoices in general, or to the customers specifically? Date formatting, that's very important, because sometimes, as we said, the due date might be very not, it doesn't make sense, a number that doesn't make sense. So it's very important to actually look at those. Yes, customer country could go wrong if it's redundant. It doesn't make sense to, if we have one column that's actually redundant, that has all the customers are from the same risk, from the same country, those 2 columns are useless now. Okay. Any other suggestions that we could go wrong? We said that the amount there is an issue maybe in the amount, maybe it could be a 0, might be a negative, might be the currency, there is a wrong part in the currency, the dates the types of the dates might be an issue. Okay, a very important question. Where is the target variable here? I'll try to be quicker. We have to validate the amounts, yes, because we need to make sure that the amount distribution, and this is what means that we need to look at the amount to see if there are values that doesn't make sense. Going back to the target variable, is it actually the invoice payment date? So if you remember, what they said, we want to see if the customer will pay early or late. So early or late, how can we say this early or late? They said that we would define a threshold 3 days. 3 days after the due date. So how can we actually kind of create this target? It's not exactly the payment date, but we will be using the payment date in calculating the target. Yes, exactly. Payment date minus due date to get the difference between the payment and the due date. This difference is actually the behavior of the customer. Is it late or early? So this difference is if it's 0, 1, 2, 3 days, it means that the customer paid 0 at the due date. If it's negative, then the customer paid before the due date, then it's early. If it's greater than 0, it means that the customer paid after the due date. And the business told us that they want the threshold to be 3 days, meaning that if the customer paid before 3 days, and this is an early customer. So we kind of have what we say kind of a rule that says if this difference is less than 3 days, then let's say that this is an early customer or early. Other than this, else it's late. So now we have actually the target variable itself. So business technically know, answering the question, the behavior of the customer in overall. They know that this is a late customer because this is what the data says. This is the performance of the past. They want to predict in the next performance because a late customer doesn't always mean he will pay all invoices late. He might pay certain invoices late and others early. And sometimes the customers actually change their behavior because they are people, they're human beings. And for FMCGs, if you're looking at big FMCGs, honestly, the customers here are not individuals. They're not me and you. They're actually big companies. And sometimes big companies try to perform better. For example, for whoever is responsible for these payments might focus more and therefore would make the payment early instead of paying late. So and a problem like this would help my company who's trying to analyze, or our company who's trying to analyze this, is this we want to, first of all, we want to save the effort. We want to actually have save the effort of people who are calling all with the same way, reminding them all with their due dates. We know, like, knowing it like in business is something, but actually confirming it with data and analysis and predictions is another level. That's why sometimes they would actually prefer to confirm their analysis with those data set and with data science problems. And also I told you sometimes the customer doesn't always have the same performance. And actually another very point that actually I learned is that sometimes if your customer is performing in different countries, so maybe you'd have a big customer, any big supermarket that is working in different countries. They're working in Egypt, they're working in different countries. Their performance or their behavior in the payment might differ from country to another. So we can't just say that this big supermarket is always paying late. No, it might be paying late in Egypt because the financial process in Egypt is different than in Jordan, for example. So that's why, for example, sometimes taking into consideration the country of the customer is very important. So yeah, and what types of plot that we can plot, we already discussed. We can do the univariate analysis. We can take for every univariate analysis, take every column that's actually relevant for us to see, for example, the invoices amount, what's the distribution, and by plotting, we can actually see if there is inconsistent variables, inconsistent values. We can plot the invoices over the due date as a line plot to see overall the amount over the time. We can see the number of items in every invoice. If it's actually, if we can have, for example, very large number of items, that could be very crucial for us or critical for us, that we can ask the business, do you allow a customer to buy 5,000 items in one invoice, or this is a wrong number? The customer country, how many countries do we have and their distributions, the risk categories, and so on. There is a very important point that someone mentioned. We need more details about customers, like age and much more info. And here it can help us in the feature part. We can discuss it next. So yeah. And we can definitely, of course, maybe, for example, do some sort of a distribution, a correlation analysis or correlation plots between the different features as we already did. And okay, let's move on next step, which is the pre-processing. So we already discussed that we have data and we already explored the data, and now it's about time to prepare the data. We analyzed it, let's prepare it, which is based on the exploratory data analysis. We get the data, we join them together, we apply all the steps here together, and we apply all the steps that we already mentioned, and pre-process the data by them. So we mentioned how to extract the target. We didn't have the target because sometimes, as we can see, we don't exactly have the target that the business wants, and sometimes extracting the target is much harder. It's not like doing a minus between two columns and that's it. No, sometimes it's actually more, takes more job. So target extraction, we need to, if it's needed, calculate it. And we move on to the feature engineering, which is a very important part, which we can also take a lot of time to discuss, but we can also dig deeper in it, which means we can create new features, we can get new features outside our data set, can extract features from the existing ones, can transform the existing ones, we can select from the existing ones. We have a lot of things to do in this phase. And to just summarize, output of this data pre-processing is basically the data set ready. So usually I prefer to say the data exploration or understanding and data pre-processing phases, usually the output of them is to have a data set ready to input in the model. So we mean that we need to transform all the transformations and do everything before inputting the model. So it's the file that we put it in the fit, for example, function of the model. Okay. Let's dig deeper in the feature engineering. I thought I saw a lot of questions about it. So let's discuss it. So yeah, feature engineering is basically we're trying to transform raw data into features that are suitable for our machine learning models. It's the very basic thing that we say machine learning models does not understand text or words. We need to understand strings. We need to turn them into numerical representations. So this is when we kind of explain to business. But yeah, so we have a lot of different things under it. First have the feature transformation. Before even digging in the feature transformation, the comment that someone left that we need more information, sometimes we can ask for more features. So this is actually something that we did before in different projects. So you actually have very few features. If we go back, the actual features that we have are basically, if we disregarded the customer ID and invoices ID after grouping the data, and the document, the due date and the payment date, we will just get from them the payment behavior. And by the way, the payment due date will not be there in your data. If you understand, this will not be there in the future data because it's actually the answer. And so you kind of have the customer country, the risk category of the customer, the number in the invoices, the amount of the invoice, and the date the invoice done. So you only have 5 features, and they might not actually be enough for us to predict the payment behavior of the customer. We might need to ask for more information. For example, let's give us more information about customers. If this customer is a person, let's get more information: the age, the where they live, their social level, whatever company. The big companies really do have a lot of information about customers, but sometimes we need to take into consideration this point is that sometimes the customers, there is some sort of like security things. You can't really use certain things for the customers if you're like GDPR and so on, and security and privacy of the customers. For example, we can't really use in our data the customer names because it's actually breaching this privacy thing. So for me, the ID is, I don't really, when I say this is this ID, yeah, I can't really put the customer name in it, and even the ID we kind of remove it or use it modified. So sometimes more information about the customer will be a bit critical depending on what type of information you want to get. But of course, if you have information about the customer characteristic, like for example, if you're in a big FMCG and you have a lot of different business lines or business units, you might see which business unit this customer belongs to. If you have kind of a segmentation of the customer size, if it's a big customer or a small customer, if you have a customer a segmentation of the customer sales or turnover rate of this customer, and so on. If you have more information about the customer, and again, this would help in discussing with the business, understanding from them, so we can get more information. So here, the most of the information that we have are related to the invoices. Sometimes some companies would have certain payment terms to the customers, like some customers have certain payment terms, like they only pay after 30 days of the due date, for example. So those payment terms are important. If we're talking at a person, a customer who's an individual like us, not a business, you might of course see, the income level if you have, or the social level, if the person is married or not, they have kids or not, the total purchases, and so on. And for example, maybe in telecom companies, they might have some information like this because the customers, you already know if you have a family group or a family line or something, so they know that there is a father that has 3 daughters and the son and the wife, that they have this group package together. So we now kind of have more information about this customer. Okay. Of course, Facebook knows everything. Okay, let's dig more deeper into the feature part. Feature engineering. Okay. Other than getting additional features, we already have certain features. We now want to do there are some certain transformations that we can do to the existing features, and we can also do what we also call extraction, which is extracting new features from the existing features, and then selection from all the features that we have. Let's start with the transformation. Transformation means transforming the exact feature that we have right now. We have two types of features so far, or variables, the categorical and numerical. And we know basically that categorical features, we don't really input them as the way they are, specifically if they're words and strings. So what we do is basically encode them. And the very, very common thing is like one-hot encoding, which is basically instead of saying, for example, country, we have countries, we can have Egypt, Saudi Arabia, USA, Germany, and for example, you have 6 countries in your data. So instead of encoding, instead of putting them as the same countries, you just encode them by, for example, giving every country a different code. And then, for example, or for example, there's a lot of different types of encoding. We will not cover the exact types, but we'll cover the concept. So the idea of encoding, for example, is that instead of putting the values as they are, you encode them in a numerical way for the code, for the model to understand that they're actually categorical. So one-hot encoding, for example, what it does is that basically, if you have 5 different classes, 5 different countries, you put them in 5 different columns. So now you have a column that says Egypt, another column that says USA, another column that says Germany. And if the customer is in USA, then you put 1 in this USA and 0 in the rest, and so on. And what's very interesting in this case is that sometimes the customer can perform in more than one country, as we already said. So we can say, so you can actually see this in this point. The other thing is the numerical. We have numerical. Why do we need to transform numerical? Because the code or the model already understands, yes, but sometimes we want to do some binning. By binning, we mean if we have a customer with age, we can have ages from, let's say, 20 years until 70 years. We have around 50 different, we have 20 to 70 years. So sometimes it could actually enhance the model performance better, instead of having all those numerical, is to, for example, bin them. Let's have the 20 to 30 as a category and 30 to 40 and so on. This is one suggestion. Also, another thing that that might make us transform numerical variable is the distribution. Sometimes we try to make the distribution as normal as possible, or they're very skewed, as someone said. Like most of the values lie in a certain place. Most of the values are between 0 and 10, and we have some values that are in the hundreds. So in those things, we do the scaling, transformation, or the normalization. The whole process here, the scaling is basically trying to put them all in the same scale. And there is a lot of different scaling, and kind of a specific version is the normalization. It's a certain normal scale trying to change the certain or transform your numerical feature to be normally distributed. Distributed, yes. So these are all trying to make all the features kind of represented like in a certain way. Of course, transformation would help us in avoiding the skewness. You might do the log transformation in certain variables to have some sort of not very skewed distribution. So all of those transformations are what are we trying to do? We're trying to make the distribution of all the column a bit similar to each other. Here, for example, what's very important to look at, if we're having the amounts that to be paid are in different currencies. So we need to make sure, okay, for us, that they don't make sense that they're very different, but we need to take into consideration that they are in different currencies. So the first transformation to do is actually to change them all to one currency, and then what to do, and then see how to deal with the other transformations. So it's very important also to look at this. And sometimes those transformations might even deal with not very outlier values, and sometimes they actually highlight the outlier values, and then you look at how to deal with outliers. Honestly, from the business perspective, sometimes what we do with outliers, sometimes we just remove them, because, and if they're not very, like if it's only one customer that's an outlier, then just remove this customer out of the 500 customers, and let's deal with this customer on their own, instead of, for example, what we say, replacing the value of the outlier and then messing up with the data. So replacing values of the outliers, replacing even the missing values when we don't know how to do this, or we don't know the business expertise behind this, it might actually mess up with the data and introduce bias to our data. So this is about transformation. Extraction is basically extracting from what your features having. So we can combine different features together. And a very nice thing that we can do in this our example is to combine the customer and the country, because you can look at the customer performance in every country and not not dealing with the customer as a whole. You can do some aggregations, and by aggregations we do some getting the average, the total, and so on. For example, here what we have, the amount, the invoices amount, and by you can get, for example, for this customer, the past amount, the past average for the invoices they paid, the maximum they have paid before, the minimum, the average, the sum, so on. These are things that we can extract from originally from data here. If you know the extraction also from date features. And so if we have a date, we can extract the day column, the month column, the week column, the year column, a lot of columns, date features. We have the dimensionality reduction here, which means that basically if we have a lot of features, hundreds of features, the dimensionality reduction is basically like PCA, for example. Again, not being able to get into more details today, but the idea here is that we can combine together different, like we reduce the dimensionality by actually building, like from the past features, we build new features that are less in the dimensionality. Yes, I know there are 30 minutes. Okay, so so the idea again of the normalization is to try to, so the normalization, scaling, or transformation, normalization and scaling, it's basically you're trying to have the scale of all values together. For example, I'll give a very, sometimes the amounts paid for the invoices, maybe you'll have people paying $10 and $1,000, for example, or $100,000. They're very, the scale is very big. Maybe you try to put them, because the model now is trying to predict a very sparse matrix or a very sparse distribution. Maybe sometimes we'll try to make things closer. That's why we kind of do the scaling or transformation to make things a bit close in the same, what we call the same basket. Dimensionality reduction. So there is this PCA method that we do. For example, if you have, and sometimes it's done, not all, we don't do it technically in the day-to-day machine learning, but sometimes maybe in the image pre-processing and so on. But the idea of the dimensionality reduction using PCA is basically creating new features, creating a new feature that is basically a constituent of all the past features. So this new feature contains something from all the existing features. So you can actually use one feature that has information or representation from all the existing ones. So now you reduce the dimension of your data, but at the same time, the new feature contains data from all the other features. So you did not lose information. This is a very brief description. I can't really get into more details right now due to the time. But again, we can discuss it afterwards. I can send you links to understand it more. There are very useful tutorials for this. And then we move on to the selection. Someone just said, okay, we can select due to the correlation. So we have two ways to select features, two common ways. The first way is to filter based on the correlation with the target feature, meaning that before actually applying any model, you look at the correlation between all your features and the target variable. And again, we have to take into consideration the type of the variables when you calculate the correlation between them, because some correlations can be calculated between numerical, and some correlation can be calculated between numerical, and some calculations can be calculated with the categorical features. So it's better to first understand what are we trying to calculate the correlation between, like it's numerical, categorical, and we have also a list for this. There are certain ways to calculate the correlations between different variable types, and then we choose variables that have high correlation with the feature, with the target variable. And why is this? We try to get variables that are basically, by correlated means when it has some sort of an effect on it, it's kind of correlated. So when this thing increases, this increases. So it will actually help in the prediction of the model. The other, which is the wrapper method, is basically waiting until you build a model, and after building a model, seeing the effect of every feature on the model performance. So actually we wait we wait to build a model and see the effect. For example, you choose a subset of the features and put the model, and then you choose another subset and you train a model and you see the difference in the performance. And then, of course, there is many different ways in actually getting the feature importance in models. Maybe you can add subsequently, like every feature, add one feature at a time, or remove one feature at a time, backward and forward ways. But again, we don't want to like get into very more details in this part, but there are two main ideas: either to select features before applying your model, or after applying your model by looking at their effect on the model performance. And again, here, there is not always a right answer, because sometimes, so we know that sometimes features are really not relevant at all. Maybe you can apply the filter method at the beginning, like just look at the correlation and have some sort of an idea. Okay, those are the highest correlated features. Still, I'm not going to remove the others now. I will apply the model and then see if also the low correlated features with the target variable, because sometimes you can have the feature interaction between features, like some low important feature and high important together, they would affect the model results. You won't know until you train the model and see the results using those two features. So quickly jumping into our scenario, we already have the columns, and now we can, what are the features that could be extracted? So for example, of course, you can type in the chat. You can start suggesting until you type. We can, for example, get features from the dates. As we say, a date, the day, the month, the year, and so on, the quarter. And then, for example, you can see the customer ID and the customer country. You can, for example, combine them together in one feature, and this actually might be your unique identifier instead of the customer ID on its own. You can hear, of course, the customer country and risk category. If they're categorical features, you will do what we call, we will do the encoding. We can also get aggregations of the invoices amount. So the past invoices amount, you can even create a feature. So first of all, for the invoices amount, you can get the past average, the past sum, and so on for every customer. The last 1 month sum, the last 1 month average, the last 2 months average, and so on. These are features that you can actually use. Another thing actually you can also calculate from here is that the difference between the due date and the document date. So sometimes you might actually create it and see if it's important or not, to see how many days between the day where they created the invoice and the day of the due date. This might actually affect. So all of these might be features that we can extract, and we can also add other features if we have additional features about the customers. So moving next to the modeling and evaluation. And basically, we already, a very important part in the modeling evaluation is basically to select training data and or divide your data set to training. So how do we ensure the model performance is very good? Is basically by having some way to test our model performance and evaluate it. How we test it, there are a lot of different ways. One way basically is to divide your data set to training and testing. So you train your data, train your model on a certain data, it learns the patterns from this data, and then you test the performance of the model. We have more methods for evaluating the model performance, which we will discuss now. But one thing that's very important when you select the data, when you divide your data into training, you're sampling it to training, testing, or hold out data set, as we'll explain now, is that you need to make sure that your distribution or that the data is actually representative, meaning that if you, for example, if you have in your training data, 90% of the training data is early, but 10% is late. While in the data and the testing data, you have the opposite. For example, 90% are late and 10% are early. So what you're doing is actually you're training the model mainly on early payers, and you're testing it actually mainly on late payers, and the model will not perform as well as you think, because the model is not well trained on late payers. So that's why it's very important in the beginning, when you train the data, prepare the training data is to basically make sure that it is representative to the actual population distribution. So if my actual data distribution is basically 80% early and 20% late, this distribution must be kept in both the training and the testing data set. So this is something. The other thing is basically to also take into consideration the time. So sometimes problems like those, it's important to take care of the time consideration, meaning that the payment behavior of the customer in the past invoice is the payment behavior of the customer in the current invoice is dependent maybe on the past. So when you divide your data set, you shouldn't, for example, put some data in the future in the training and test on the data from the past. If you're taking into consideration any time aspect, you'll have to divide your data or split your data on a time perspective, meaning you sort your data by time and you take the first amount as a training data and then you test on the future, but you don't train on the future and test on the past. This also kind of maybe add something that's called the data leakage that we need to take into consideration when we're evaluating the model or when we're also training the model, because it's as if you're saying to the model that the customer in the future will pay good, but so it's as if you're doing a data leakage. What does data leakage means? It's as if you're giving an answer to the model, giving the answer inside the training data. So as if you're, for example, saying putting the due date, putting the payment date in the training date. If you put the payment date in the training date and the payment date is empty in the cases where the customer didn't pay yet, and it's actually you're actually giving the answer to the model. So it's a data leakage. You don't want the model to know the answer and inside the training data. So again, the idea is not to kind of what we call, it's not to give the model the exact answer or help it like to make unrealistic good answers, because this is not how the model should be built. The model should be trained on the behavior and predicted. So this is one type. The other type is, as we said, putting future data in the training and then for example putting past data in the testing. So you're making it in the opposite. One of the ways, so now we kind of selected the training data and we trained the model and we want to evaluate. We all have different ways to evaluate. One of the very common ways is the cross-validation, which is basically you want to, you kind of divide your data set, for example, into five folds. You train on 4 and then you test on the 5th. And then you take another 4, you train on them, and you test on the 5th, and so on. Here you make sure that you're taking all your data set into consideration while training and testing in the model, and therefore you make sure that your model is not like what we call overfitting on your training data, because sometimes your model actually memorizes your training data and does well on the testing data, and then when you get new data, it's really doing awful. So the evaluation of the model is very important to do as much important tests to make sure that there is no leakage, to make sure that you're taking into consideration there is no overfitting, and then you can do the feature selection here, which we know we already discussed. We can do the feature selection after testing different models, choose the different features or the most relevant features, the most important features in our models, and finalize the model. Is this the end? No, it's not. I'll kind of skip this part. We already know that this is a classification problem if we're doing an early or late. But I want to focus on, we already discussed also the different leakage options that could happen. I want to discuss this important phase, which is the deployment and monitoring. Because sometimes data scientists think that it's okay, it's done. We don't really need to do anything after deploy the model, after we actually finalize the model. But it's very important to focus on the deployment. In different companies, you might have some people supporting you But for example, in our case here, we need to ask some questions. We need to ask how the prediction should be done. Is it a real-time prediction? Is it daily? You get daily predictions daily data that you need to predict, or it's a batch predictions. I'm going to send you predictions every month to do data every month, and you apply predictions and get them back to me in an Excel file. How will the business consume them? In our case, the business wants to consume them in a Power BI dashboard. So we kind of want to generate the predictions in a place and connect it to Power Dashboard. It needs to be a real time because they want to have daily predictions. So it's a daily, it should be connected. So our system, if we imagine it, it should be connected to the data source. We're using pipelines to our code where we do the predictions and then save those predictions somewhere, and then the business would consume them in Power BI. So we need to create this connection to Power BI dashboard. We need to have someone creating this Power BI dashboard that they want to look at. And then we have this hypercare period. Do we create the model and create the dashboard and run away? No, we have to make sure that our results are actually as we expected and as we reported. We told you that the accuracy is 80% and the performance of the model is like this. We want to make sure with time that this actually happens. And that's why when you deploy machine learning models, it's very important to have this hypercare periods. My meaning, give some time for you and the business to test, to do the user acceptance testing. By meaning the business side, they need to kind of see if the model is actually doing what they want it to do. Is it actually doing what it meant to do? How is it doing? You from your side monitor that the pipelines are working fine, that the performance of the model in 1 or 2 months or 1 to 2 weeks is actually working fine. And not only this, plan for monitoring, plan for retraining. By planning for monitoring and retraining, what do we mean? Right now, we deploy the model. We decided with the business, okay, we will have 1 month for the user acceptance testing and the hypercare period. Let's connect in 1 month. Let's see if the results are going fine. You connect and yes, the results are going fine. Let's move on. The model is deployed. What if new customers are added to the company and those customers have different payment behavior than the ones? And now the model starts to perform bad. The results it starts to go down. And the business, they don't know if actually the predictions are right or wrong because you did your testing and you moved away. That's why monitoring is very important. To have live monitoring solution that monitors your current solution, for example, every month, every quarter, depends on how frequent it works. It monitors the performance. If you see that the performance starts to go down, then it's about time to retrain. Sometimes actually people agree with the business on specific times to retrain the model every quarter, every once a year or something, if they know that additional data will be added. If no additional data will be added, then maybe they will just do the retraining ad hoc depending on the monitoring. It's better for you to build a very complete solution. You know, when your model starts to go down, you know when to retrain it. You don't depend on people coming to you from the business and saying your model is not performing well, it's doing bad, it's making us lose money, and so on. And finally, the output here is actually a deployed model. It's ready for consumption and a complete solution from the start of getting the data to the what we call to the idea of having a solution that has a monitoring solution that's ready and that gives you whatever any notification if there is something wrong in your model, if there's something wrong in the pipelines that's going on. So if we look here, the output here we said is going to be a Power BI dashboard that contains our predictions and how we can test the model. We can create a user acceptance testing with the business. Like, for example, they can, assign a certain employee that would monitor the performance of the dashboard daily and see if the predictions do make sense, if we don't predict things that doesn't make sense. As you already say, they already have information about the payment behavior. If they see that they know that this is the customer is paying late most of the time, but then they figure out that all the predictions are that this customer is paying early, then there is something wrong. Maybe there is something wrong. Then that's why we need to have this testing period and discussion ongoing with the business and build a monitoring tool. How can we monitor results like this? Here we're trying to figure out if the customer is going to pay their invoices late or early. Monitoring this might mean that we can every month or 2 months run a monitoring code that sees the actual paid dates when the customer paid and compare this to our prediction. So we predicted the customer will pay early, meaning 3 days before, but the customer actually paid after 10 days. So this is a wrong prediction. So it's very simple. Just match them and get the accuracy metrics again and see. So yeah, this is actually like summarizing this point here. So let's look if you have any questions. Try to kind of summarize the idea of data science life cycle. We did go a bit quick at the end, so you might have any questions. That's why I prefer to leave those 10 minutes for questions. Try to have them as much as possible questions related to our content today. If you don't have, we can discuss general questions if you want, but let's look at the relevant questions first. If we had time, we'd discuss other questions. If you want me to repeat anything in the process, it's fine. I know that it's a bit too much. There is a lot of things to do, and like I know that a lot of people asked how to do this, how to learn to do this. It's a great part of it, of course, it's experience, and this doesn't mean that if you don't have this experience you won't really get jobs. No, because that's why there are entry level, intermediate level jobs and senior level jobs. So if you're working as an entry level job, you learn this. If you're in intermediate level job, you kind of have some sort of knowledge about this, and it's very gaining knowledge from this also means that what you say, you need to focus more on the projects, because sometimes people just focus only about the data science part, or not the data science, the modeling part, and skip everything else. And when you jump to another job, you figure out that you should have focused for all. Just here are my contacts. If anyone wants to send an email or just talk in LinkedIn, send me a message and let's connect. Do we have to collect more features about customers from social media? Again, I will tell you here, it depends on the customers, it depends on the company, because sometimes companies won't prefer that. So if you're looking about individuals, I'm not sure how how correct is it for all companies, because you're kind of taking data from customers. If a customer, of course, leaving their data public on Facebook, for example, or social media channels, it's kind of, we kind of consent that anyone would take our data if it's public, but not all companies prefer to do this. And again, depends on the customers. So of course, data, unfortunately, good and bad thing, of course, data on social media channels gives a lot of information about customers. Not sure how ethical this is in all companies. Go to the slides of the modeling and evaluation. Sure, let's, sorry. Modeling and evaluation. Here you go. Data understanding, and in the Q&A we have some questions. Data understanding and pre-processing is the job of data engineer or data scientist. So I think it's both, because again, it depends on the company, because in general, a data scientist should know how to analyze and pre-process data, but in some companies you actually get the final data, but still you're the data scientist and you're the one who knows the problem. So you might actually do, so data engineers, when they do the pre-processing, what they might do is that just make sure that there is no missing values, there's no inconsistent values. But sometimes the pre-processing, there are some things that don't make sense, like very large amounts. They might, as a data engineer, they might not know if it's really large in a bad way or large in a good way. So you still need to do this pre-processing step. For me, I always prefer that the data scientist knows how to do everything, the data analyst and the data scientist. Data engineering part honestly depends on the company, because some companies you do everything from scratch and then you learn an additional skill like the data engineering, some you don't. That I'm trying to catch as much questions. Access the session of the recording sessions. I don't know. Is to code your model better, to use machine learning with ready tools. I prefer to code, honestly. I like coding and changing and trying new things, but I don't know if you have machine learning models ready, because sometimes the tools, they're not really, you're not able to customize them. The machine learning ready tools, you just give a certain things, you're not able to customize a lot in them. So I prefer to be able to customize and play with the code. That's why I prefer this. I think the job market question is going to take a lot of time. So unfortunately, I won't be able to answer it right now, but we can discuss it anytime later. I can send you the slides. I can contact the team and send you the slides. So tools to use. So if you want to code, if you by tools you mean coding. So for example, I do prefer Jupyter notebooks. I think they're, for me, I like to code in them. You can see different IDEs. Maybe Google Colab. It's easier if you don't want to make anything on your laptop, so your laptop is not easy to install everything. How to estimate it? Thanks. This is a very good question. How to estimate ETA and timeline for each life cycle phase, as business overview is different than the SVU of the tasks to perform. So the idea of estimating the ETA, the timeline, and so on is very crucial. It's very, I don't have the correct answer because I'm still learning, honestly, this in my job. Every project we do it in a different way. I think it depends. First of all, if you have someone with you, you have to combine them. If you have a project manager, if you have a manager who's working with you, if you have a team, you have to discuss this together. And you need to decide the phase, how long it takes. So you know your company. If you know the business of this company, they're people who don't know what they want. They take a lot of time. You can plan a lot of time for discussion. And if you have someone for data, you know the data is easily there. You don't have to plan a lot of time in getting data. But if you know that the business or your company, for example, takes a lot of time to give you access to the data and allows you to build pipelines and so on, you build more. So it depends on your company, on the type of the business, on the type of the project. I have some projects that I can deploy in 1 month from end to end. Some models would take multiple months because of the discussions of getting the data and errors and so on. So I think it depends, and you look at every task. If you have experience, you look at every task and see normally how long it takes you. I always prefer to take some buffer time, add some buffer time when you expect, because sometimes business are not really friendly when you take more time than expected. So if you take buffer time, that would be good. If you don't have experience, definitely seek help from people with you in the team. Or if you don't have people in the team having experience, seek help from other people. For example, discuss with someone who has a background, the certain type of the problem, so you can think together how long it might take. I didn't use SAS, honestly, I think I just used it very past in the past, but I think machine learning and AI, if you want to do coding, then Python and R are best, most probably Python. How do we do that? And we need to do and how do we do that? And we need to know how to deploy in website and mobile app too. I can't tell you right now how to deploy in website and mobile app. We have only 2 minutes. And how to do that by meaning the pre-processing coming from the user to machine learning. The pre-processing is what we already covered. How to do the pre-processing by analyzing the data and doing the steps that we got as an output. If you don't know how to code, so if with having people that you kind of don't know how to code, you need to know coding. There's a lot of things we can also connect. I can suggest to you different specializations and different courses and tutorials. There is a lot of tutorials. That's why I didn't want us to do coding here. I thought of discussion more because there is a lot of free tutorials that you can just watch and show you how to code the different things from simple to complicated things. You mean user data. So generally for the pre-processing part, just quick info is that basically when you get the data, you create pipelines. So you save pipelines. This pipeline is trained on how the shape of the data originally is, which we got at the beginning, and then you kind of have inside this pipeline different steps that you apply, and then your final output is the data that's input to the model. So this pipeline is created. Now when we're training the data, we know what exact steps we are going to do to our data set. And then we create this pipeline, train it on the exact data, and then when we have new data, we just apply this pipeline. It's as if you're saving the pickle of the model and testing it on new data. I know time is off, but I'm not sure if anyone okay, regarding again the how to work in data science, how to start in the data science part, we can connect in LinkedIn. I kind of have prepared the document before when I did a previous session about getting into data science that can help you in learning more or starting with this career. We can connect regarding this. Is R helpful in data science? Yes, but depends on the company. For me, I prefer Python. Most of our teams work with Python. Query big data and data science journey, you might. It depends on the data you're getting. It depends on where you're getting the data and the amount of data and the project, but you might. And sometimes it's actually you can have some people in the team to help you. Sometimes you'll have to learn it and by your own. I'm putting my contacts again for anyone. I thank you everyone. I hope it was kind of beneficial. I know it was too much. I honestly thought we'd have more time for questions and discussions and feedback. You have my contacts. You can contact me anytime. We can discuss anything, and yeah, thank you so much. And have a nice rest of the day.
Thank you, Rania, and it was very interesting. And thank you everyone for attending the tutorial. We will have a short break now and see you back here at 3:45. Thank you again. Goodbye.
Thank you. Bye.